Welcome back to Topic 6, Session 2, the last one of this course. Now we will translate what we have discussed in the previous session into the MEDEAS language. First, we will get familiar with the scenarios interface in MEDEAS. After that, we will run the world model and show some examples. Finally, we will finish the course with some concluding remarks. MEDEAS software needs an external spreadsheet file with the inputs required to define parameters, constants, policy targets, and scenarios. This file is the one named inputs, low dash, and the uppercase initial of our geographical model. In this case, we will use inputs W for MEDEAS world scenarios. First of all, make sure the inputs file is in the same folder as your MEDEAS module file. Otherwise, it won't work. To begin with, we should get familiar with the interface. Here you can see the initial README tab, where all the other tabs are briefly described. It's important to note that they are only our self-defined scenarios, which do not necessarily match other scenarios defined in the literature, like the above-mentioned SSPs. Some of them are for scenarios, but you can also check the different parameters and constants that we have used for every module. However, in this course, we are only focusing on scenarios, and particularly on business as usual and scenario 2 scenarios. Because the business as usual scenario is based on current trends, we are learning scenario management in MEDEAS through scenario 2, which we can say that reflects a green growth narrative, and which usually describes a scenario with a deep energy transition along with the high economic growth rates. Throughout these tabs, you will be able to set different policy targets from the economy to energy, including your personal option on nuclear power or the desirability of an afforestation program. Of course, for the sake of simplicity, we are only looking at the most representative values in order to understand the rationale of scenario design in MEDEAS. We will also run our scenarios, then changing some options to see how sensitive the model is to the figures we choose, and finally comparing two different scenarios. As mentioned in previous topics of this course, MEDEAS is a demand-led model activated by GDP per capita and population scenarios. So we will first define economic and demographic growth here. You can see for both of them different options in a gray background. You can take either the SSP values, define your own time series year by year, set a constant rate or an asymptotic target. If you want to use SSPs, just put a 0 here and here. For GDP per capita, only SSP2 is defined. So let's put the same option for population growth, 2 zeros. In case you want to define your own time series, you only have to move to the right and set up your final simulation year and your preferred annual rate, which can be increasing before reaching a peak and then going down, or whatever you define. It's up to you. Don't worry about having values set up here, even though you don't want that option. As long as you have set the model to choose a particular option, it will disregard the other ones. It doesn't matter if there are values in here. Therefore, if you want the model to take your own time series, you should put a 1 instead of a 0 in column B. Scroll down and we can start setting scenarios for energy resources. As mentioned throughout the course, and especially in the energy module lesson, MEDEAS is an integrated assessment model that considers energy limits, not only for non-renewable energy sources, but also for renewables. Here, the maximum potential for different renewable energy sources is set based on the literature. But if you want to set higher values based on your own estimations or on other literature estimates, you can just change it. Actually, if you think that renewable energies are not biophysically constrained at all, you can also put a 1 here. And they will be unlimited, and it will disregard all the figures below. For our first run, we are setting all energy sources as unlimited. So we set a 1. From row 31 and on, You can set the expected capacity installed growth by technology. You have hydropower, geothermic for electricity, solid bioenergy for electricity, oceanic, onshore and offshore wind, and solar photovoltaic. Then you can also set values for techno-ecological potential bioenergy, a projection of different bioenergy technologies, biogas, waste, and heat. Then you can select your option for non-renewable energy source extraction curves. You can take oil disaggregated into conventional and unconventional by putting a 1 here, or aggregated as total oil by setting a 0. Then, in each one, you can select the extraction curve based on different literature estimates. They are all the same for gas, coal, and uranium. Take oil, for instance. Here we have selected total oil aggregated extraction curves and the estimates from LARER. You don't believe in the limited nature of non-renewable energy sources? You can just make any of them unlimited by putting a 1 in the applicable cell, or all of them at the same time by putting a 1 here. And that's what we are doing for our first run. Please note that if you put a 1 here, it will disregard everything else. But if you put a 0, you can still make any of the non-renewable energy sources unlimited. More options. If you scroll down to row 199, you will find the energy intensity options. Energy intensity is trickier than this, but just to make it simple, we will only play with these values. If you don't want the energy intensity to decrease, or in other words, you want no energy efficiency gains, put a 1, otherwise a 0. Here, you can set how low the energy intensity can go. In this case, we are imposing a minimum of 30% of its initial value. Here you can decide to change intensities by sectors or only by energy sources. Put a 0 if you want to make it globally for energy sources. Then you can change here for each final energy source the maximum rate that energy intensity improvement can reach for a year. Here we have set a maximum of 1.5% decrease. In row 317, you can activate or deactivate climate change impacts. Here we are keeping climate impacts deactivated, a rather conservative choice. Finally, in row 337, we can change the option for economic structure represented by technical coefficients matrix, the so-called A matrix. As explained in the economic module lesson, put a 0 here if you want to keep it constant with the last observation's value. Put a 1 and copy-paste the matrix that you prefer, and finally put a 2 if you want the A matrix to evolve according to historical trends. For option 1, it can be a completely made-up matrix, or you can use an actual country A matrix. In order to show you an example, the value scenario is set with 2, evolving according to historical evolution. And scenario 2 takes the A matrix for a modern renewable energy supporter like Denmark. Now, let's run the model and see the results for scenario 2. Remember that the purpose of this module is not to discuss outcomes, but to learn how to define and run scenarios in MEDEAS. So just take these results as examples. We will call our first simulation test. We can run it by clicking here. After a few seconds, we will be ready to see some examples. In order to see the graphics, you need to click on any variable and then here. Please remember that all energy sources are unlimited in this simulation. We can see some examples for GDP, the share of renewable energies in the energy mix, and total CO2 emissions. You can see how GDP rises steeply, which apparently should be good news. But if we had a look at the share of renewable energy sources, we can see that it's not very impressive, and CO2 emissions just skyrocket. Why does this happen if we have set high values for the installed capacity of renewables, a modern economic structure of a renewable energy supporter, and a high drop in energy intensity? It's because high economic growth, together with the unlimited nature of non-renewable energy sources, made it possible to rely on them for a longer period while the energy transition was being deployed. We can write a model with energy limits in order to assess the differences. Should the energy limits be considered, economic growth would be stopped at a certain point, because energy scarcity made it possible to grow only at lower rates. Conversely, we find better results for renewable energy share and emissions. We can see that in MEDEAS, given the scenario values that we have chosen, a sort of trade-off between high economic growth and energy and climate goals appears. Finally, we can compare these outcomes with a hypothetical business as usual scenario. We will run it with limits to make both scenarios comparable. Here we can see different outcomes for the same variables regarding these scenarios. In MEDEAS, we can also impose a transition scenario to begin policies earlier or later on the simulation period. The results might vary substantially considering the delay to implement the transition policy targets. We can do this by changing the initial year cell that appears next to the different policies in the scenario tabs in our inputs file. To summarize, we can highlight the following conclusions. First, integrated assessment models, IAMs, are enriched by scenarios. Second, the shared socioeconomic pathways, SSPs, is the most common scenarios framework. Third, MEDEAS accounts with a flexible scenario structure for the user to decide. And fourth, comparing different scenarios allows the modeler to analyze the sensitivity of different policies and contexts. This has been topic 6 and the end of the course. We hope that you found it interesting and useful. See you soon.